Hello, I'm Charlie Engelke, and I work in developer relations for Google Cloud Platform. My focus is on serverless computing, and today's talk, we're going to see how you can run almost anything serverlessly using Google Cloud Platform. This is important to me because I was a software developer for many years outside of Google, and I always wanted to make the path from it running on my machine to it's live on the web as short and simple as possible. And that's what serverless computing does. It lets the developer's path be as short as possible from when your application is working, as far as you as a developer are concerned, until it's working as far as your customers are concerned. Serverless computing has a life cycle that, to really break it down to its simplest possible terms, is the developer builds the app, tests the app, makes sure it's all working in the local environment, and then the platform takes over and does everything else. It provisions computing and storage resources. It handles logging, monitoring, health checks, patching, hardware problems. All that stuff is the responsibility of the platform. And as a developer in the past, that's what I really wanted to do. I wanted to focus on my application, not on the platform. So serverless computing is great, but it does have a deal you've got to make as a developer. If you want to use a serverless computing platform, the platform offers you this bargain. I'll provide you specific runtimes, that is to say, environments for your app. And if you want to use me, you're going to have to fit into one of those runtimes. That's not terribly restrictive. Google Cloud Platform has several serverless platforms with a lot of runtimes. For instance, there's App Engine, which has been around for about a dozen years, and it supports half a dozen different languages: Python, Java, Node, PHP, Go, and Ruby is currently in beta. If instead of a web application, you're looking to deploy a web service, Cloud Functions is a platform for that, and it has 4 runtimes it offers at the moment: Python, Node, Go, and Java is currently in beta. So if you've got an application in any of those very common popular environments, you're set. You can use one of these platforms as it is today. But what if you don't have your application fit into one of those runtimes? For example, what if your application needs to run a binary? It's not just one piece of source code, it's several different components that run as binary code. Maybe they're in other languages. Maybe you've lost the source code or you've licensed third-party code, or they may incorporate shell scripts. There's a whole lot of things that might make you not fit into here. For example, you may have started working in a brand new language and it's a perfect fit for what you need in your application, but you can't find a platform that supports it. Well, in today's talk, we're going to talk about how to solve that problem, but we're going to give it a problem that's the exact opposite. Instead of too new a language, what happens if you need to run a 45-year-old Pascal program? To remind all of you who may not remember or may not have been around, Pascal was the most popular computing language for teaching in the 70s and 80s. And it was pretty well defined in this little slim book, the Pascal User Manual Report, written by Jensen and Worth. It was published in 1974, which is a full third of a century before any of our modern serverless platforms existed. So it's not terribly surprising that the examples weren't optimized to work on serverless computing. But it does have a program in it that we just have to make available online. I found this program and I want everybody to be able to get the benefit of it. This is it. It's a Pascal program to convert numbers to Roman numerals. It may seem fairly simple, but this has been around for 45 years. Any bugs in it presumably have been well knocked out. You enter a number and it gives you back the Roman numeral. Now, in order to do this, first thing I had to do was look and see what serverless platforms will run my Pascal software as is, and I could not find any. But I still want one because I don't want to manage my own environment. I don't want to run my own servers. I don't want to package my software and deliver it as code that people run on their own infrastructure. I want to take my application that is working fine on my local machine and make it available to anybody that's got a web connection. Cloudrun lets me do that. Cloudrun is Google's serverless platform that offers a slightly different bargain than the traditional one. The traditional bargain is, I'll give you a language environment, you fit into that environment, and you can run serverlessly. Cloudrun's bargain is, instead of just bringing your source code, you have to bring a container. Now, when you first hear that, you might think that is a lot of extra complexity instead of just bringing my own source code. You've probably worked some with Docker or seen about it or used Kubernetes, and you know that containers are extremely flexible, but there's a lot of things you can do with it and a lot of things you need to learn how to manage. Cloudrun is actually a very simple host environment for a container, and it can be very easy using tools on Google Cloud Platform in order to get this out and running. And that's what we're going to see. The easiest way to take our Pascal program, package it in a container, and let Cloudrun manage it for us. Containers can be a lot easier than you might think, easier than I thought. The first thing is you don't need to install any of the traditional container tools. You don't need to install Docker because Cloud Build, a Google service, can actually take your specification and your source code and build the container that you need for you on Google's own infrastructure, not yours. Not only that, you don't have to figure out how to build and specify this container from scratch. There are a lot of quick start examples that are close to what you need. And that's what we're going to do. We're going to take one of those and squeeze in our Pascal program with minor changes. Changes that don't require container expertise and don't require container software on your own machine. We're going to start with the Cloudrun Python Quick Start. That's at cloud.google.com/run/docs/quickstarts/build-and-deploy. If you go to that page, you'll see that there are only two files in this example. One is a very simple Python web application using the Flask framework that just says hello world. Somebody asked for the home page. It says hello world. That's it. The other part of the quick start is a Docker file that is the specification for how to create the container, which is to say the runtime that Python app requires. We don't have to change a lot to make this work with our Pascal code. We're going to add the Pascal source code to the overall example. So instead of two files, we're going to have three. We are going to make the Docker file compile it into a binary because we can't launch the Pascal program in source code. We've got to convert it to an executable. And then we're going to tweak the Python program. So we're going to keep the Python program, but instead of it just saying hello world, that program is going to invoke our Pascal executable. Let's see how that all is going to work and why it's going to work that way. The starting point, remember, is that Pascal program, written in 1974. Now, Cloudrun's bargain is, give me a container, but the container is supposed to handle web requests. Cloudrun will take incoming web requests, send them to your container, wait for the response, and send it back. That's really all it expects your container to do, is handle web requests. This code doesn't do that. That's because this code was old enough to drive before the web was invented. This code was written in 1974. Tim Berners-Lee told the world about the web in around 1990. So, not surprising that 1974 software doesn't handle web requests. Instead, it handles requests from standard input and it sends the answers out to standard output. We're going to keep it that way and we're going to let the rest of our runtime environment handle that for us. First of all, let's take a look at the Docker file. The Docker file in the example is simple. It's only 6 lines long, and to deal with our Pascal example, we only need to add 3 more lines to it. So the Docker file is not terribly intimidating. Let's take a look at what every one of these lines does and why we need it. The first line says what runtime we start with. We're given a container that can do a lot of what we need, and we just need to add to it. In this case, the container is a Python container that can run Python programs. The last line of this says, when Cloudrun invokes this, what software inside the container does it execute? Well, what it's going to do is it's going to execute the gUnicorn web server using our Pascal Flask program. Now, in the middle, we have to specify the working directory, where all the software is expected to be. We set that up to be /app. That is /app in the containers file system, not on our own local machine. And we copy all the software in our current working directory when we build the container into the container at that location. So that's how our Pascal program gets into the container. That's also how the Python program gets in there. But again, the problem is the Pascal program source is in the container. We need the executable. So the next 3 lines install software to do that. We're using the standard Debian package installer, and the first line is to update it so that when we install, we get the latest versions. Then we install FPC, which is the free Pascal compiler. That's available, and it will actually do the job we need in the next line, which is to compile our roman.pas source code into an executable. By default, the output of that compilation step with the free Pascal compiler will be a file called roman. Our working directory is /app. So we're now going to end up inside the container with /app/roman as a binary executable. All these run steps, by the way, are happening while the container is being built. Once we have a container, they'll all be finished and they'll be ready to go. And then the final run step we have in here is installing the necessary Python prerequisites. We're running an application that uses the Flask framework, so we have to install Flask, and it's running under the Unicorn web server, so we have to use the Python package installer to install that as well. When the container is built, all this stuff will be executed and run, and we'll be ready to go ahead and have the web server run our code. Well, our code, as we say here, is going to be the Python app launched under the Unicorn web server. So let's take a look at that Python app. The starting point in the quick start is a simple hello world, and the Flask framework basically says, here is a path that might come in for a request, and here's the code you run to respond to it. So we have here at app.route / the home page path, just plain slash, will run the hello world method. And all that method does is it checks to see if there's an environment variable that should say hello to that instead of hello world. By default, it then falls back to using hello world, and then it returns that string, hello world. That's it. Very straightforward, very simple. What we need to do is modify this so that it actually takes a number and figures out the Roman numerals for the number and sends the result back. So first of all, how are we going to get the number in there? Well, the easiest way I know of is for somebody using their web browser to put it in the URL. So instead of requesting the web page at /, request the page at / some number. In Flask, you can specify that as a placeholder and then say when you run the hello world method, pass it that number, which will be bytes. We convert that to a string, and now we have something that we're ready to ask the Pascal program to parse and manage. So the next step is to run the Pascal program using the Linux subprocess module. We tell it to run our executable, which again is at /app/Roman. We tell it for standard input, send it that string that we got, the number to be converted, and to capture the standard output, which will be our Roman numerals. And then the final step is instead of returning hello world, we're going to return the standard output from when we ran the Pascal program. That's it. Not a lot of complicated changes. Let's go ahead and take a look at how to do this with Cloudrun. We're going to have to start by building the container. So let's go over to a demo where we get it started, because that can take a few minutes because installing that free Pascal compiler has a lot of prerequisites. After we run this command, we're going to come back here, talk about how the command worked and what we need to do next to actually get it to run. We've created all the pieces of our application, and now we want to have it running on the Cloudrun platform. In order to do this, we've got to create a container, and we've got to then send the container to the Cloudrun service. That can all be done from the command line on your local machine, but I'm going to actually do it without anything installed locally. And in order to do this, I'm going to the Google Cloud Console at console.cloud.google.com. This site is where you can create a new Google Cloud Platform project, and everything you do is going to be in the context of a project, so we have to create one. And your project is going to be a name you give it, in my case, Engelke Next, and it'll create a system-wide project ID, which in many cases can be the exact same thing if the name you picked is globally unique. I'm going to build it still with the command line tools, and in order to do that, instead of running them on my local machine, I'm going to activate Cloud Shell. Cloud Shell comes with the Cloud Console. Any web browser can let you connect to it, any modern web browser, whether you're on Windows, Mac, Linux, a Chromebook, you name it. Once you connect to it, it's going to give you a pre-provisioned Linux instance, and you can run the commands there. Let's take a look at what's already in my instance. I've been here before, so I've already got a directory with the source code we've seen so far in it. There are a couple of ways you can get that source code onto your Linux instance for Cloud Shell. One is you've got tools like Git already installed, so you can get something from a Git repo. Or you can use the commands over here in a menu to upload files from your local machine. There are a variety of ways to do it. In this case, they're already there. So let's take a look at the files that we created and go ahead and build the container. We want to build it in the Google Cloud Platform using the Google Cloud Build service. The command for that is gcloud builds with an S, submit. And then we give it a tag so we can find it later in order to deploy it. That tag is going to be in an artifact repository in gcr.io. In this case, I've named it based on my project, Engelke Next, and I've given it a service name. It could be pretty much anything. Since this is for Roman numerals, I picked a service called Roman. If this is the first time you use the Cloud Build service, you may be prompted that it's got to be activated. And it'll offer to do that for you. It'll add a couple of minutes to do the build. Normally, building a container can be relatively quick, but in this case, it's going to take quite a while, and that's because we have this container installing software, including the free Pascal compiler. That turns out to have an awful lot of dependencies, and it's going to take a while to do that full build. So we're going to go ahead, go back to our talk and see what the commands actually mean that we've just done. And we're going to see what other commands we need to do. We'll come back here after this build is finished. All right, what we just did was use the Cloud Shell in the web console for Google Cloud Platform to actually invoke a command that's going to run Cloud Build and build our container. Let's take a look at all the pieces of the command and what we asked it to do. The first part is the gcloud command line tool. We could run this locally on our own machine, but if we did, we'd have to install it. And we'd also have to set up credentials on our local machine saying that we are authorized to actually build a container using Cloud Build. If we do this all under the Cloud Shell, everything is set up for us ahead of time. So we can run the gcloud command, and we want to run Cloud Build. The subcommand for that is builds, build s. And what it's going to do is create a container using the specification in the environment. We can specify it a lot of different ways. By default, it's going to look for a Docker file in the current directory and use that. After it's done, we want it to submit that container somewhere so it's ready for us to pass on to Cloudrun. We're going to submit it to an artifact repository and tag it with a name that is based on our current project ID. As you saw, the project we were working on was called Engelke Next. I used my name to make it globally unique, and then / the name of a service. And we can use just about anything for that service name. We used Roman because this is a service that's going to give you Roman numerals. Once that's finished, and we'll go back in a minute and see that it's finished and go on to the next step. Once it's finished, we're ready to then ask Cloudrun to go ahead and take that container and deploy it serverlessly. And we use the same gcloud command line interface to do it, but in this case, since we're talking to the Cloudrun service, the subcommand is run. So it's going to be gcloud run. And then the action we want it to perform is to deploy it. We need to tell it what image to deploy, and it's in that same artifact repository, and we tell it how it was tagged. And then we've got to tell it where to deploy it, because Cloudrun is available on Google Cloud's platform fully managed, but it's also available on an environment you manage, either on Google Cloud or somewhere else, like your own infrastructure. We've got to tell it which of those to deploy. And as you saw from my talking about how much I like serverless, you know I like to do the least and have the platform do the most, which means I want to deploy it to the managed platform. And then the final thing we have to put in here is something about who's allowed to run this, because by default, Google Cloud Run will require all web requests coming in to be authenticated and will only actually pass them to your Cloud Run container if they're authenticated by somebody you permit. Well, this particular service, the Roman numerals, is too valuable. We can't hold it back from the world. We want everybody to be able to do it without any authentication. So we include the allow unauthenticated flag. Let's go ahead back to the demo, run this command. It doesn't take quite as long to deploy it as it took to build it because of that install step we had in the build. And then we'll see how it actually works. The container is finished building. We can see that it was a success and it was pushed. So now we can go ahead and deploy it with the gcloud run deploy command. Again, if it's the first time you've done a Cloud Run deploy, you may be asked to activate some APIs, and it'll do that for you. In this case, that's already been done, but it's going to ask what I want to call the service, and it will infer from the tag I gave it that I want to call it Roman numerals, that's a good name, and then where to deploy it. I'll go ahead and deploy it to the US Central 1 region. Now I'm going to deploy the container, and this takes a few minutes because it's not only got to deploy the service, it's got to set up access control, even though we said allow unauthenticated, and it's got to set up traffic routing so that everything gets to this cloud container properly. Once it's finished running, we'll be able to go take a look at what the URL is and actually invoke it. So while this is still going ahead and running, let's go ahead and in the top part of the console, go take a look at the Cloud Run part. And we can see this is being built. It's not finished yet. If we take a look at the details, we'll see it's still in progress. Once it's finished, this will show us the URL. Right now it says it's loading. And after it finishes showing us the URL, we'll be able to invoke the service just by opening a web page at that URL. If we didn't tell it allow unauthenticated, we'd have to send an authenticated request, one with a header that contains proof of our identity. This is going to be a lot easier in this case. All right, the revision deployment is finished. It's been deployed. It's serving 100% of the traffic. And here's the URL. When we invoke the URL, we're going to be disappointed right at first. And that's because it comes back with an error message. Well, that error message is not Cloudrun's fault. Our Python wrapper program told how to handle URLs that had slash followed by a string that we were going to interpret as a number. This URL does not have that string, so we didn't tell it how to handle it, so the Python wrapper function just doesn't know what to do with it and returned an error. Let's go ahead and tell it we want to take a look at the Roman numeral for 1974. And it comes back and gives us that. It's not in the shortcut for Roman numerals. When they wrote this program, it was easier to write it this way and clearer for the purpose of teaching. But also, the fact is, in the earliest days, Romans didn't tend to use the shortcut versions anyway. Let's try another number. You may have noticed when you were looking at my console that I am doing this recording on July 20th. That is the anniversary of the first lunar landing on July 20th, 1969. So let's take a look at 1969 in Roman numerals. And again, it converts it right away. Anybody in the world that knows this URL can go ahead and do this conversion as long as this is live. The next slide, once I show it in the demo, will actually have a URL that I'm going to be leaving live for a few months if you want to try it out yourself, or of course you can deploy your own. Now, this is not a very easy URL to memorize or give to other people. You can, if you have your own domain, actually configure Cloudrun to respond with a page at one of the URLs on your own domain. We're not going to cover that here. It's fully documented in the web pages. Okay, as you saw, it was pretty easy to actually create the container without having any local install and to deploy it to Cloudrun. And now it's available on the internet for everybody to access. That URL that I did in the demo is for a throwaway project. It's not going to keep running for very long, but I still have this available at this URL on this slide, so you can come back at any time and you can go to that web page because you probably need to convert numbers to Roman numerals all the time. We're going to keep this application up for the next several months, not promising it forever. Now, again, this is not the world's friendliest URL to memorize. It is possible to actually use your own domain and have your own URL pointing to the service as well. We're not going to cover how to do that, but it's fully documented at the website. We have now seen that you can run almost anything serverlessly. And you do that by creating a container, and containers can be easy with Google Cloud Platform, with Cloudrun and Cloud Build to create them. You can do that without any local Docker install, and if you use Google Cloud Shell, you don't need to have anything on your own machine except a web browser, which, if you're watching this talk, we know you've got a web browser available to you. You can start with a lot of Docker file samples that are close to what you need, so you don't have to learn how to create Docker file specifications from scratch. And in fact, depending on what you need your container to do, you may not have to have a Docker file at all. Build packs, which are described at buildpacks.io, that website, can eliminate the need for a Docker file entirely. They can actually look at your source code structure and create the container from that. I don't think you're going to find a build pack, however, that can handle Pascal. But all is said and done, everything we did here is something you're probably not going to need to do exactly as given. You're probably not going to need to run Pascal software on a serverless platform. But it's a lot more likely you may need to run something in a language that's too new to have much support on source code oriented serverless platforms. And in fact, it's extremely likely that your application is going to have many components that include pieces you've already got in binary only form, either because they've been around for your company for a while, you've lost the source code, or possibly you've licensed them in binary form only. Or you may have other old languages, unlike Pascal. It's a lot likelier you may need to run old Fortran or COBOL programs. All of those are things you can do now because Cloudrun greatly expands the universe of software that you can run serverlessly. You can run almost anything. That's what we promised, but there are a couple of restrictions. We mentioned that your software is only going to be run in order to process web requests. Cloudrun's not going to invoke your software unless it has a request for it to respond to, and after it gets a response, it's going to stop your software from running. So you can't leave anything running all the time in the background. The other restriction is your software's got to be stateless. If you put something in your source code that, for example, has a global variable keeping account of how many times you've received a web request, well, every time a web request comes in, it may be going to a different container and affecting a different global variable. It's not going to have any meaning. If you need to keep state, don't keep state in your container. Keep state external to it, for instance, in an external database. So I hope this has been useful, that you have seen that learning how to run a 45-year-old Pascal program on a modern serverless platform can show you some other techniques that actually are more applicable to your general use. If you have any questions, please use the Q&A. We'll be answering them as quickly as we can get to them. And again, thank you very much for your attention.